This presentation is about the deliverable D3.5, the Trust Management and Identification Platform. The demonstrator shown in the presentation uses a vehicle to verify a valid software update, which is based on the W3C verifiable credentials stack. For the purpose of the demonstration, only one verifiable credential will be verified. The design of the trust management platform follows the decentralized identity management ecosystem, defined by the W3C, which can be seen in the top left corner. Here an issuer certifies a holder with a credential. The holder presents the credential to a verifier. The verifier is able to verify credential data via the distributed ledger. In contrast, traditional PKIs issue credentials, which originate from root authorities. To issue a credential in the trust management framework, an authority first registers a credential schema on the ledger, which is a template for credential values. Next, the issuer registers a credential definition on the ledger referencing the credential schema. The credential definition contains cryptographic material used for the verification of an issued credential. After a credential has been issued, the holder can present the credential to a verifier, in addition to verifying signatures and credential attributes. The verifier checks against credential revocation. The nIoVe Trust Management Framework builds on the software stack of the Hyperledger Indy framework, and uses the VON network to host the blockchain nodes. The authorities rely on the Ares Cloud Agent Python code, and the revocation verification is handled via the Indy Tails server repository. The entities in the nIoVe Trust Management Framework are as follows. The government is represented in the nIoVe Admin Authority, which registers credential schemas for the vehicle and software authorities. The vehicle authority is represented by a vehicle registration authority, and the software authority embodies a software certification authority. The vehicle registration and software certification authorities act as issuers. Next, a vehicle and a cloud server act as mutual holders and verifiers. In a software update, the vehicle verifies whether the cloud server has a valid credential of the software certification authority. The cloud server verifies if the vehicle has a valid credential of the vehicle registration authority. The demonstrator shows the bootstrapping of the nIoVe Trust Management Container Network. The bootstrapping phase deploys all required agents and interfaces for the software update. The agents are the government or admin party, two issuers in form of the vehicle registration and software certification authority. A cloud server and a vehicle agent is holders and verifiers respectively. The demonstrator shows the credential schema, the credential definition, registration and the issuing procedure of a credential, as well as the presentation and verification of a verifiable credential. The container network starts via a Docker Compose script and is shown in the left terminal window. The Ledger web interface shows all active blockchain nodes and initial transactions after the Genesis transaction. Next, all agents are spawned via another Docker Compose file, and the bootstrapping can be seen in the right terminal window. Every agent has a web server which hosts the interface per agent. The interface of the nIoVe admin government agent is used to register a public DID on the ledger. This agent is later used to register credential schemas on the ledger. The issuing authority registers a credential definition on the ledger, and issues a credential to the holder, which is the cloud server. The credential can be inspected via the VON network web user interface. The agent running on the vehicle creates a proof request for the software update verifiable credential that is proven by the software certification server.